رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Projectile motion refers to the motion of an object that is thrown, projected, or launched into the air and is subject to the forces of gravity and air resistance. Some examples of projectile motion include the trajectory of a missile, a kicked ball flying through the air, and the launch of a rocket. Look at the ball. It will move in a parabolic shape after being kicked. The missile also moves in a parabolic trajectory. Finally, have a look at this rocket motion.
About 20 seconds after liftoff, it'll start pitching over to the side.
Projectile motion involves movement along two-dimensional axes. How do we analyze this type of motion? Figure shows a parabolic trajectory of a projectile motion. Assume an object tossed up in the air, with a velocity v-note, and the motion is portrayed in this figure. On each point of trajectory, there will be velocities along x and y components as shown. However, at the highest point of the trajectory, the velocity along y-axis is 0. There is only velocity along the x-axis. Throughout the projectile motion, the velocity along the x-axis is constant, hence, the acceleration along the x-axis will become 0. While moving in a projectile trajectory, an object will experience two types of displacement, which is the horizontal displacement and vertical displacement. The horizontal displacement, indicate with the symbol of delta x, is the measurement of displacement which the object travels along the x-axis. Meanwhile, delta y is the measurement of the vertical displacement of the object's motion. In order to solve for a projectile motion problem, both x and y-axis needs to be treated separately. The kinematics equations of motion can be applied as shown in over here. Take note the ax is 0 and ay is always negative 9.81 meters per second square.